Hi, thanks for joining me today. I've got a fun AIME problem I want to show you. This comes from the AIME 1 paper from 2020, and this is problem 3. Okay, so we have a natural number n, such that when we express n in base 11, it takes the form ABC concatenated. So this bar just above means that we concatenate A, B, and C, and I'll explain what that means in just a second. Okay, furthermore, when we express n in base 8, it takes the form 1BCA concatenated. Okay, and we want to find the smallest such n in base 10. Okay, so what does this concatenated mean? Well, it just means, so ABC concatenated just means I shove the numbers A, B, and C together. So normally ABC would just mean A times B times C, but when we concatenate them, that just means we stick them together. So for example, if we have A equals 3, B equals 7, and C equals 2, then ABC concatenated just means 372. So if we're working base 10, that would just be 372. Okay, so we want to find the smallest such n with these two properties and express n in base 10. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so we have base 11 and base 8. What we want to do is just work under a common base, and that base being base 10, because that's what we want our final answer to be in, and also that's the base that we're all familiar in. Okay, so n is equal to ABC concatenated base 11. What does that mean? Well, let's just look at an example base 10. So we have 372. I think that was what I used in the when explaining what concatenated means. So 372, and we're thinking of that number base 10. Well, that's precisely 300 plus 70 plus 2, and that is 3 times 10 squared plus 7 times 10 plus, or 10 to the 1 times 2 times 10 to the 0. Okay, and that's kind of how you define base 10 numbers and how you write numbers in base 10, and the exact same thing goes for base 11 and base 8 and base any other number as well. Okay, so we can write n base 11 using this ABC expression as the sums of powers of 11. So let's just rub this out. So we have that in base 11, n is equal to ABC concatenated, and that just means A times 11 squared plus B times 11 to the 1, which is 11, plus C times 11 to the 0, which is just 1. Okay, so n equals this thing here, which is equal to 121A plus 11B plus C. And the exact same thing holds when we look at this base 8. So we have that n is equal to 1 times 8 to the 3 plus b times 8 squared plus c times 8 to the 1, which is 8, and plus a times 8 to the 0, which is 8 times 1. Okay, expanding this out, we still have the a. Let me work out what 8 cubed is. Well, 8 squared is 64, so 8 cubed is just going to be 8 times 64, which is 480 plus 32, so that's 512, plus 64b, plus 8c, plus a. Okay, so we have two expressions for a, and these are now both base 10. N equals 121a plus 11b plus c, and it also equals 512 plus 64b plus 8c plus a. And of course we know that n equals n, so we can set these two equations equal to one another, and then we can make some progress in working out what the minimum such n is. Let me clean the whiteboard, and then we'll continue. Okay, so I've just written up the two expressions we have for n, which we just derived. N equals 121a plus 11b plus c, and that also equals 512 plus 64b plus 8c plus a. Okay, now just sort of staring at this, you might think it's impossible to work out what n is, because a, b, and c are kind of variables, at least for now. We're not really sure what they are, and there's kind of three unknowns here, and we want to kind of work out what that is. We only have one equation comparing the three unknowns, so it kind of seems like we're not going to be able to solve that. But if you think back to what we started off with, we want to find the minimum such n. So theoretically, if we had a computer, we could just start from 1 and work all the way upwards, because we know n is a positive integer, and keep going, adding 1 to each number, checking if it has that form base 11, has that form base 8, and eventually, provided there is a solution, we get to that solution. Okay, so this is indeed solvable, because I think the crucial bit is we want to find the minimum such n, because otherwise there might be multiple solutions. Okay, but anyway, we have n taking this form here, and what we want to do is just do this thing minus this thing, which of course is just going to be the same thing as n minus n, which of course is 0. So we have that 0 is equal to this guy minus this guy. So 121a minus a is just 120a. 11b minus 64b is just minus 53b. C minus 8c is just minus 7c. And then 0 minus 512 is just minus 512. Of course, we just want to put all the negatives on the other side just by adding them. So let's do that, and we get that 120a is equal to 512 plus 53b plus 7c. Okay, now where do we go from here? Well, we know that b and c are non-negative. They have to be at least 0. So this right-hand side here has to be at least 512. So that tells me that a must be at least 512 divided by 120. But if you remember, a has to be an integer. It has to be a digit from 0 up to 9. So a must be an integer, so it must be at least the biggest integer bigger than or equal to this thing. Sorry, a must be at least the smallest integer bigger than or equal to this guy here. And if we just look at the multiple to 120, it's 120, 240, 360, 480, which is just below 512, and then 600. Okay, so this guy here is somewhere between 4 and 5. So this number here is going to be 4 point something. But because we require a to be an integer, this implies that a is at least 5. Okay, so we've worked out sort of a lower bound for a. And then what we want to do is actually see, well, if there is a solution for a equals 5, if we have a equals 5, can we find b and c satisfying the equations? Then we'll be done. And then of course we know that that will be the minimum, because any other value for a will be bigger than, will have a bigger. And then if we recall that n is just equal to abc, when we look at it base 11, so sort of this digit here has the most influence. So if we increase a, so if a was at least 6, then no matter what this number is, so if we have some number of the form 5, and then we're looking at it base 11, so 5, say 10, that number there is going to be less than 6 BC, no matter what B, C are. So even if B and C are both 0, then this thing here is going to be less than this thing here. So what I'm trying to say is if A equals 5 and we can find a B and C satisfying the above, we'll be done, because that will be the minimum solution. So let's see if we can do that, and then if we can't do that, then we're going to have to try A equals 6, A equals 7, and so on. Anyway, let me clean the whiteboard and we can continue. Okay, so now we're going to try A equals 5 and just plug it back into the equation we have here. So 5 times 121 is 605, plus 11b plus c is equal to 512 plus 64b plus 8c plus 5. Just bringing the b and the c onto this side and all the numbers onto this side. Well, 64b minus 11b is just 53b. 8c minus c is just 7c. And then bringing the 512 plus 5, which is 517, onto this side, we get 605 minus 517, which is 88. So 88 equals 53b plus 7c. And now remember, b and c are non-negative integers, so we just have to test some cases. And it's quite clear to see that there are only 2 cases when b equals 0 and b equals 1, because if b is at least 2, then this guy here is going to be at least 106, and this guy here is obviously at least 0, so we have 106, something that's at least 106 on the right hand side and something that's 88 on the left hand side, so there's no way they can be equal. So we only need to check the cases b equals 0 and b equals 1. Well, when b equals 0, we have 53 times 0, so this thing here vanishes, and then we have 7c equals 8, and well, 88 isn't a multiple of 7, so there's no integer solutions then for c. So that isn't a valid solution, so we just have to check b equals 1. And in that case, we have 88 equals 53 plus 7b. Well, then just subtracting 53 from both sides, we get 88 minus 53 equals 7b. So 7b is equal to 88 minus 53, which is equal to 35. Okay, and that of course implies that b equals, that's supposed to be a C there. Oops. So there we go. That implies that C equals 5. And of course that is indeed an integer. So we have found an integer solution in the case A equals 5. And because this is the only one, it's thus the minimum one. If we had found a solution when B equals 0, that would have been smaller. But because there's no integer solution there, but there is one for the case B equals 1, that is the minimum such solution for n. But let's just construct what we have again. We have A equals 5, B equals 1, and C equals 5. And then if we recall, the n is just this thing here, so we can use either expression. They're both going to amount to the same thing, but we can just plug them back in to work out what n is. So let's just make some space here. So n is just equal to 121 times 5 plus 11 times 1 plus 5. 121 times 5 is 605 plus 11 plus 5. And that's just equal to 605 plus 5 is 610 plus 11. So this thing here is just 621. And that is our final answer. 621. So yeah, that's a pretty cool problem. I quite enjoyed it. It used just essentially how we can convert from the base of an integer into something we're more familiar with, namely base 10. And then we just made things equal one another, used the basic fact that A, B, and C are each non-negative. And actually A had to be at least 1 because it was the starting digit of the number. But yeah, so, and then yeah, we just used some inequalities and used some cases, and then we were able to find that A was equal to 5 and that B was equal to 1, which gave us what C was. Anyway, I hope you have enjoyed this video. Thanks for watching. I'll catch you in the next one. Have a great day.